Hey everyone, geophysicist Stefan Burns here. We have had a bunch of solar activity over the past few days. Boom shakalaka! That was an 8.5 M classifier that blasted off from sunspot group 4114, launched a solar storm our way, and that was followed up by a 6.4 M class flare. So getting close to X class territory, especially with that first one. And then following that 6.4 M class flare, there was a plasma filament that blasted off a little bit closer to sunspot group 4115, which sunspot group 4114, this big one right now exactly on that Earth central meridian, it's moving to that. And so there's two big opposite polarity sunspot cores getting closer together. We have lost a little bit of magnetic field complexity in this big sunspot group 4114 over the past 24-36 hours. But if those two come together, we could see renewed really big flare activity. And you'll notice through this entire video that really kind of electrical activity we see has not at all stopped or slowed down. So sunspot group 4114 is still very, very active and alive. And it's not the only sunspot group that's been flaring on the sun. We've also had some significant solar flares from the western limb here from 4105. Actually, that launched some pretty significant solar storms out into space to the west. That would be like towards Saturn and Neptune at this moment in time. They do forecast some flank impacts potentially from those coronal mass ejections just because of how significant they were. And this is also expected to be kind of a weak impact due to the fact that most of it got sent off to the north of the ecliptic plane. But looking at this holistically, we've had a bunch of flares and solar storm launched from here. We've had a bunch of flares and solar storms launched from there. We've also had this plasma filament, a whole bunch of other things kind of happening too. And so in general, the solar wind is really enhanced right now and it's headed our way. This may not be the biggest solar storm impact of all time, far from it. But I think this solar storm impact is going to be more significant than may be modeled. And we'll also discuss how the Earth may respond to this solar storm impact, because that's the other half of the equation. Right now, our ionosphere is at about normal charge. It's not especially supercharged or anything like that. Our radiation belts are right around normal in terms of their flux levels or energy level. And we are getting really close to solstice. So in general, we are not predisposed to have the strongest solar storm impact, but if these two sunspot groups get close together, that could give us a very significant explosion on the sun over the next 24 or 48 hours. That would still have this be right in that central meridian zone, and that could be a bigger solar storm impact than from these other ones which are currently launching to the north. And so we are right now in a heightened zone of solar activity and space weather that's going to continue out for probably like the next week or so. We do have a new active region also rotating in from the far side of the sun, and so that could undergo some significant solar flux just like 4114 did, continuing this period of heightened space weather activity, which is what I'm forecasting based on planetary geometry. That really clicks in on June 21st. I think a strong magnetic storm is likely right around that zone, but it continues all the way out to the end of June. So a lot of activity from our sun. We're going to do a complete breakdown in this video. Let's get right into it. And let's now zoom in on our 131 angstrom imagery of the sun, which shows these solar flares really nicely. So we can see these really big explosions on the sun, many times the size of our Earth. And so you can also notice that electrical activity, that buzzing and crackling, that lightning-like activity in the background on 4114 in between those flares. That is one of the main signs that I look at in terms of assessing whether a sunspot group is about to go. And it hasn't really slowed down, as you notice at the end of the video. Even though there has been a little bit of loss of size of that sunspot group, it's not that much, but it has diminished slightly. But the electrical activity, you could say, looks still very, very active. It's now exactly on that central meridian. We are losing sunspots because of 4105 and some of those other sunspots on the western limb rotating out, now aligned up with that planetary geometry of Saturn and Neptune to the west, as well as soon Venus and Ceres, the dwarf planet, all in that alignment. And then to the east, that would be the left side of the screen, that side, we also have Mercury and Mars lining up exactly on the 21st of June. And so that's the planetary geometry. Jupiter directly behind us, the Earth in front, and we have this big sunspot group that has just been blasting out solar flares, causing significant radio blackouts across the globe, and right now it's on the central meridian. Here we have our latest C2 and C3 chronograph imagery going from June 14th up to today. You'll notice a whole bunch of coronal mass ejections blast out into space. You'll also notice this very bright object there. That is Jupiter performing a superior conjunction very, very soon. It's on the far side of the sun. As a result, it's reflecting a lot of sunlight back our way. It's also entering into this perfect gravitational vector 180 degrees opposite the Earth. Keep that in mind. We saw with the last Cazimi, that would be Mercury, that really big solar flare and solar storm that launched out directly towards us. And so that could perhaps trigger similar dynamics. Mercury is a little bit different. The fact that it's much closer to the sun, has a very high orbital velocity. The Birkeland currents from the sun, these field-aligned currents, actually connect down in the core of Mercury because it doesn't have an ionosphere or any significant conductivity in the exosphere beyond the surface of the planet. It has to actually connect down at the core. Perhaps that's implicated with some of these interesting electric circuit dynamics of the sun and in general of interplanetary space of the solar system. Jupiter is much farther out at 5.2 astronomical units on average, but we do have it coming in. It's the big plasma and gravity heavyweight of all the planets, soon to be exactly opposite the Earth. But let's look at our coronal mass ejection specifically, and let's look for that one from that 8.5 M-class flight. We'll see it mostly launched there to the north, but we do get a push out in all directions. So let's look at our differential view so we can really precisely see that. Here we have our same chronograph imagery, but this time set to a differential mode, which allows us to see these solar storms a little bit better at times. We see this first one here, and we see a bit of a push to the left and to the south. And here's the 8.5 M-class flare, much more obvious. Most of the plasma going to the north in both of those, but clearly we do see a bit of an Earth-directed push. And so that's two that are headed our way. Again, not the strongest, but looks like there is an enhancement of the plasma headed towards Earth from both of those. And then you'll also notice a bunch of coronal mass ejections here launched from the western limb, especially the one after that 8.5. We see that coming here. That is likely to give us a very slight flank impact because these solar storms usually spread out more than often anticipated, or that these models show. The dynamics of the plasma interplanetary space, it spreads out often to a greater degree. And so we just see a whole bunch of plasma being shot to the north of the ecliptic plane, but some of it clearly still along that ecliptic plane, the Earth-Sun plane. A lot of it going to the west out towards Saturn and Neptune, but also likely spreading out a bit more to give us some flank impacts. And you put all that together, at least in my mind, it looks like we have some significant solar activity that's soon going to be impacting the Earth, probably around tomorrow, the 18th to the 19th. Maybe it's a little bit late. So right around that time frame, and we have that sunspot group on the sun still very, very active. Let's check it out. Here we have our latest 2 days of sunspots on the Earth-facing side of the sun, so we can really zone in on 4114 and see how it's been changing. Here's our most recent 4K imagery. Still a very large, complex sunspot group. This is the core from 4115, and you'll notice in this video that this is slowly moving closer to this one. So it's also extending its time in that central meridian zone because of that eastward drift. So give this a watch. You'll notice that about 36 hours ago, it was at its largest, and then we do see a slight diminishment in this sunspot cluster near the end, though still quite significant. But look at how it's getting closer, and over the past 36 hours, this main core has still been growing because a lot of these little cores are kind of feeding into it. So this one's getting bigger. That one also maybe it's grown a little bit, but in general, they are getting closer together and they have an opposite polarity. And so that could get quite explosive pretty soon. The other sunspots on the Earth-facing side really haven't done too much. In general, our sunspot numbers are right at the estimated monthly average right now, which is maybe about 115. We were up at 150. Now we've gone down, but we do have this new sunspot group that's rotating in soon from the eastern limb, though it's not that big, but perhaps that helps this sunspot number go back up with some new flux pushing out. In general, though, this is our sunspot story. We've been at low levels in May. Now we're going up to higher levels in June. We have a big flare player right now on the Earth facing side of the sun, right there in that strike zone. And we're all waiting for perhaps a really significant explosion to launch a big solar storm our way. But we do know that we already have some enhanced levels of solar plasma headed our way from all these explosions that have been occurring on the sun. So the question is, how is the Earth going to respond to this? And to better answer that, we have to examine where the Earth is geophysically at this moment in time. And so one of our most important variables is the ionosphere. The uppermost part of the atmosphere has a charge to it because it's about 1% plasma, that fourth state of matter, very vibrational. Effectively, you have the molecule or even just the element split apart. Electrons fly off from the central nucleus, which stays positively charged. And here we're measuring the total electron content across the entire vertical column. We use GNSS receivers for that because you have these GPS satellites flying around in space, and their signal strength and the ability to communicate with them depends on the charge of the ionosphere and the electric potentials, the currents, all that stuff. And so we can look at our vertical total electron content to get a sense of the overall state of the ionosphere. This is 0, very low total electron content. Here we have 100, very, very high. And so if we look at this model, we see that everything's around moderately charged. There's nothing that's like supercharged at this time, like we've seen before. If you follow the channel and you've watched a lot of the videos, I'm sure you've seen some of that imagery. That's more common during the equinoxes. And so that segues to the other important factor, which is that we are approaching solstice. And in general, there's not the strongest connection between the solar wind during solstice periods, whether that is the June solstice or the December solstice. It's during the equinox periods, that's March and then also September, and also the month after each equinox, which would be April and October, that we have a really nice connection between the solar wind and in general an enhancement of the electron density around the Earth in the radiation belts and also in the ionosphere. And so right now we're moderately charged in the ionosphere. That's important as it relates to a solar storm impact in a geomagnetic storm, because it's the electric currents of the ionosphere that create those magnetic field swings that we feel at the surface, and also that generate those geomagnetically induced currents, which can cause problems with technology like power grid failures or more from those extreme solar storm impacts, which we do not have coming our way yet from what's been launched. That we could get a really big solar flare from that sunspot group, but as of right now, that has not happened. So we're looking at probably like G2, maybe G3 storming from what's already happened. It's hard to kind of put a number on it. Space weather is really hard to exactly predict, but in general, we have some stuff coming our way. But this solstice effect is going to kind of probably cool things off a little bit, and then the ionosphere isn't necessarily supercharged at this moment in time, ready to make things very volatile and enhance those electric currents, create stronger magnetic field swings, which is how we measure those geomagnetic storms. So that's also not a factor. Let's check out our radiation belts. And here we have our radiation belt forecast. In fact, this data goes from June 10th all the way up to today, showing the flux levels of the radiation belt. Here's our legend, same color scheme as the ionosphere one. So blue is cool colors, red is high flux. You have a lot of ions, protons, electrons, and maybe even helium ions in the radiation belts when it's at these colors. And you'll notice that in general, across this entire time frame, things have been moderate in the flux level. They're hanging more around the yellow and the orange, sometimes dipping down a bit into like the teal, the cyan, and the blue. And so we're not supercharged with the radiation belts. This is important because during a solar storm impact or some other sort of solar wind structure that's significant, that will cause all these highly charged particles traveling at relativistic speeds near the speed of light, so they have a ton of energy to them. It'll cause them to precipitate down into the ionosphere and generate those stronger electric field potentials, and therefore those electric currents, those geomagnetically induced currents, stronger magnetic field swings, so on and so forth. But right now we're just at moderate flux, and so we're not going to get necessarily an enhanced effect from the radiation belts as they are right now at this moment in time. This is an important factor to consider as it relates to forecasting the effects of a solar storm impact and therefore the space weather. Another important factor is the magnetic field and its orientation at the moment of that impact. And so that's kind of difficult to predict because it requires you to know precisely when that solar storm is going to impact. And sometimes we're accurate with that, other times we're a little bit not as accurate. But if you have the magnetic field tilted really nicely directly towards the incoming solar wind, then it'll funnel in a little bit easier. Whereas if it's kind of bulged out and like leaned back, it'll flow off the magnetic field a little bit easier. And that's actually why, one of the reasons why during the solstice we have reduced solar storm impacts. It's because of the tilt orientation of the magnetic field to the solar wind. And there's more to that story, but this is an important factor for like the most precise forecasting. The radiation belts are another important factor. The state of the ionosphere is another important factor. These are all the geophysical energies of the Earth herself, and therefore how she'll connect to the larger electromagnetic circuit, you could say, of the solar system, of the solar wind, and of the sun. Because these currents that flow down from the solar wind, they actually connect in at the ionosphere. So the stronger an ionosphere, the more flow you can get through that circuit, and therefore the more significant the solar storm impact. Looking at our USGS latest earthquakes map for the past 7 days, let's just quickly examine the earthquake activity here on Earth, because there is some evidence suggesting that solar storm impacts and in general just space weather has an effect on the Earth geophysically as it relates to earthquakes and perhaps even volcanoes. I find that research and evidence very compelling. Other people don't find it as compelling. I think it's just common sense, really, as someone who can feel into this intuitively, but regardless, everyone has to do their own research and make up their own mind. But you'll notice that the strongest earthquake of the past 7 days is this magnitude 6, and that actually came in right after that last solar storm impact. That was a G2 long duration geomagnetic storm. We see that came in on the 13th. And then since then, we haven't really had that much activity. The most recent significant earthquake is this 5.6 here in Peru. And that actually caused some significant shaking because it hit right near Lima. So pretty big earthquake, but not magnitude 6. If it had been magnitude 6 or even 7, that would have been a much different story, because already that caused some landslides and some damage around Lima as a result of just a 5.6. One other earthquake I want to point out here, because it got a lot of people's attention, I really kind of don't know why, is this magnitude 2.9 in Colorado. And a lot of people were like, why is Colorado getting earthquakes? Well, first and foremost, a magnitude 2.9 earthquake is like, I don't even think about it, okay? It's so minor. Now it is like pretty close to Denver, but probably not that many people felt it just because it's such a low magnitude. And in general, you are going to get earthquakes in mountain ranges because there's a lot of faults with the mountains. How do you make the mountains? You need like compression, tectonic force, and therefore you have faults. So that area isn't the most seismically active. It does not get earthquakes that often, but it's not at all atypical to get a 2.9 magnitude earthquake in a mountainous area. So keep that in mind. We have been having this earthquake swarm here in Idaho. That has cooled off a little bit over the past few days, though it is still active. Of course, you see all the earthquakes across California, and we've been having a ton of earthquakes in these oil fields in Texas. So really clearly showing the effect of oil and gas fracking. You know, basically if you just fracture up that underlying geology at 2, 3, 4 kilometers of depth or more, you're going to create earthquakes, not only through induced earthquakes through the actual fracturing process, but by loosening up all that geology, you now make it more likely for there to be earthquakes that just kind of pop off on their own. So Texas is becoming very seismically active as a result of that, though we haven't been seeing earthquakes beyond the magnitude 5 range. But still, the fact that we can do oil and gas fracking and start to induce magnitude 5 earthquakes is troubling, I would say. Puerto Rico has an interesting earthquake swarm. As you see, it's been going on now for years. Really kind of unknown as to why, but around this area there are always earthquakes if you're wondering what that is about. And we've been seeing quite a lot of earthquakes on the mid-ocean ridges, as you can see. So showing that there is active spreading at these mid-ocean ridges. Plate tectonics is alive. A lot of people are looking very closely here in the Japan area. And the biggest earthquake that we've had, again, is that magnitude 6 just north of Japan, in between Kamchatka and the North Island. So that is the earthquake activity. Nothing super, super crazy, but some interesting things to point out. So we've had a lot of solar activity over the past few days, and that was actually what I forecasted back with my last video just a few hours after I dropped that, telling you, hey, big solar flares coming. They started to pop off, so make sure you subscribe to the channel to stay up to date with what is happening energetically. We examine what's happening with the sun, space weather, and also planetary resonances. We also examine what's happening with Earth in terms of geologic events like high magnitude earthquakes and volcanoes, geophysical energies like the Schumann resonances, and bring all that together, present videos almost daily for you. So I'll keep an eye on what is happening. The most pressing thing that I'm seeing right now with the sun is the movement of the big core getting closer to the big core for 4115. If those two get close together, that could result in some very interesting dynamics. It could be quite explosive. So we'll just have to wait and see. In general, there's also been a lot of plasma filaments blasting off from the sun. It looks like we have some solar storm impacts coming in over the next 2 days or so, 2 to 3 days. It depends on their propagation velocity. And we are currently in a coronal hole high-speed stream. The solar wind density has gone down to about 1 to 2 particles per cubic centimeter, but the solar wind velocity actually isn't that high. So it hasn't been the highest velocity solar wind that will slow down these solar storms that are launching our way a little bit, but not that much because the particle density is fairly low. So that is your latest space weather report. Again, I've been your host, Stefan Burns. Thank you all so much for watching. Wishing all of you well. I'll see you all in the next video.